Hello, welcome to our session where we will show you how to take advantage of native Azure capabilities to build modern financial applications with Azure Cosmos DB. Quick agenda. We're going to take a quick look at data and application modernization trends on Azure. We'll review application modernization use case based on the high-speed trading system. And then, most importantly, we're going to show you in a demo how to take advantage of building such system using Azure components, using Azure Cosmos DB, functions running on Kubernetes, Synapse, Event Hub, etc. When we look at application modernization, usually what's needed is you start breaking down your applications into smaller components, microservices, domain-driven APIs. And as you go through the approach, you often look at to improve agility, scalability, resiliency of those application components while maintaining the cost efficiency. And what Azure provides to enable that app innovation is a set of the PaaS services to improve that agility, improve the application resiliency using Azure Functions, Azure Kubernetes. But at the same time, you want to look at the database component because every application needs a good, resilient, and flexible data store. And Azure Cosmos DB provide you that flexible managed database service, which can be flexible enough to absorb any data model which is driven by application. It can be elastically scaled to adjust capacity based on the application requirements. And then it has a built-in geo-replication and multi-master write capabilities to bring your data closer to the customer while reducing latency for database operations. If you look at cloud-native capabilities on Azure, you can see that the Cosmos DB is in the heart of managed database services, but it can also easily integrate with all other native Azure components for messaging and event stores like Event Hub and Stream Analytics, for application containers and serverless compute with Azure Functions and Kubernetes Service, and for analytics and reporting based on the Azure Synapse, Data Explorer, and Power BI integrations. When we're talking about Azure Functions and Azure Kubernetes Services, we want to highlight that we recommend to take advantage of KEDA, Kubernetes Event-Driven Autoscaling, which has integration with many Azure services based on the metrics to expose external metrics for horizontal scaling, and the operator itself, which actually allows the scalability to happen. And we're going to show you that in a demo as well. Now, let's take a look at the use case we have to simulate the high-speed financial trading system. On the left side, we have market ticker data, which comes from external system based on your subscription, which is eventually basically is a time series event data for market price and quantities based on the generation. And also you have the order management system, which absorbs the events for buy and sell from your traders, from your trading APIs you may expose to your customers as well. That data is combined and flowed into order execution system, which uses the data together to actually match buy and sell orders based on trader data. There's additional APIs in the real trading system for risk analysis, transaction cost analysis, and some other APIs to maintain those complex rule engines. And on the downstream side, there is a bunch of compliance and reporting systems for P&L dashboards, usually data warehousing integration, compliance reporting, and others. That system, usually what has in common, it is event-driven, but it also high speed and high volume with tight integration between transactional analytic systems. And all those criteria are fit well into Azure Cosmos DB as a data platform for those systems. And we're going to show you in the demo, which is coming up next. Take it away, Marcelo.
Thanks, Sergey. So according to our business requirement mentioned, how we can leverage Azure Cosmos DB to fully manage the Azure services to achieve that. The idea of this demo is to show how Azure Cosmos DB can be the best choice as the central database for your financial trading system, and how to leverage native integration with many other Azure technologies. So here is the architecture of our demo, where Cosmos DB is the main transactional database. So here is in the first path, we are ingesting market data through Azure Event Hubs, which is our scalable messaging hub service, and consuming the data with Azure Stream Analytics and storing every 15-second ticker aggregation. In this case, minimum, maximum, average, and the last position in Azure Cosmos DB. For this second path, we have the order management system receiving input orders via Azure Functions REST API and storing data directly in Azure Cosmos DB. And with this outbox pattern, once the data is stored in a container, a downstream function will consume Azure Cosmos DB change feed and publish data to Azure Event Hub for execution. And once the order has been fully executed, the results will be published back to Azure Event Hub to be updated and in the updated to update orders and executions in Cosmos. And now again, using Azure Cosmos DB change feed, second function will consume published data and update customer portfolio based on the most recent executed order. So both scenarios show us the potential of Azure Cosmos DB change feed as part of an event-driven architecture for event publishing and creating materialized views, reshaping data for consumption. And lastly here, you could leverage Azure Synapse Link for Azure Cosmos DB integration to enable near real-time analytics without impacting our search transactional system. And just to highlight here, all Azure functions are running on Kubernetes services, Azure Kubernetes Services with KEDA, so either the application and the database are highly scalable. If you want to try out yourself, here's the link to the GitHub repo and the resources diagram that will be of the resource that will be provisioned. So now let's see the platform in action. Here's our Stream Analytics service. Here's the query that is aggregating data. As you can see, we are aggregating data by a 15-second window and calculating the average for both ask and bid prices, as well as minimum, maximum for both prices, as well as taking the last position, the last price received within that time window. So let's take a quick look here in the market data container. Here in this container, we are receiving data from Stream Analytics, directly from Stream Analytics. And as you can see, we have the latest position. Every 15 seconds, we'll have this data updated. And as you can see, here, all the prices already ingested inside our collection. So for this scenario, you could create a microservice or REST API, as we're going to show in a few seconds, how to consume this data directly from Azure Functions. So let's quickly move to our APIs. So here in this API, we are consuming data directly from Azure Kubernetes Services. And if we just hit send, as you can see, we have the latest position. So every 15 seconds, we will have this data updated. And if we can, of course, change the ticker here in the path and consume a new data. So let's see the order creation. So let's simulate a customer buying 100 stocks for 1,000 Microsoft stocks, and let's create the order. So now we have the order ID, and just check the status here. The order has been created, and now let's check the order status. We're going to move to another API here and consuming the data. So just take a look. Now the status of the order is executed, and we have our last modified date here. Let's check again the executions. So one order could be broke down in different executions. So in this case, we broke down in 4 different executions. And lastly, let's see the portfolio, the customer portfolio. So previously, our customer had 2,000 Microsoft stocks. Now we have 3,000. So let's quickly create a new different order for a different stock. Let's change the price and buy a different one. And again, new order ID. Let's create a status. Execute it again. So let's check the customer portfolio. And there we go. Now we have a different asset inside our asset class, our equities asset class. Well, let's see the code of those APIs. So here is the first API that we have, the get stock price. We are just receiving the symbol and the path of our API and using the Azure Function bindings. Here, this is a HTTP trigger binding, and receiving the symbol as the path and injecting directly the symbol as a partition key and the ID of our collection, using, again, our Cosmos DB input binding in this case. And the result would be our stock price object already deserialized and ready to be returned to the color of this API. So let's see the function, the order create function. Again, using HTTP trigger binding and Cosmos output binding in this case. We just need to provide database container name, and we have the async collector ready to store orders on Cosmos. We just need to deserialize the Cosmos, the HTTP payload here, deserialize into our business object, add a couple of new features such as a new order ID, a new status, and the date time when the order was created, and just call the async collector to add the order in Cosmos. So the next API was the get order. And again, using our HTTP binding, our HTTP trigger here, and injecting the order ID received in the API path directly as a partition key and ID of our input binding. And again, receiving our deserialized object and returning to the caller API. A new example here was the get execution. So we are again using the HTTP trigger, but we are using the Cosmos input binding in a different way. Now we are providing a different query and injecting the order ID as the filter at the where clause of our query. And again, we are now receiving a list, an enumerable of our order executions, and returning the data directly to our API, to our caller API. For the customer portfolio, we used the same approach. So using customer ID, receiving the customer ID from the API path, and injecting as the filter of our query, and receiving a list, enumerable of portfolios to be returned here. So now let's jump to our executors. So here we have a different binding. So here we are using Cosmos DB trigger, and which means that once data has been created or updated in Cosmos DB, this function will be triggered. We have a couple of configuration here, such as database, container, connection. One important thing here to mention is the list container. which will be the container responsible for storing the checkpoint for this processor, and some configuration here. Now we are so once order has been created or updated in our collection, in our order collection, we are going to receive a list of objects, and you can do whatever you want. And in this case, we are using, you are publishing only created orders to our event hub to be executed. So once the order has been executed, we are now using a different approach and creating a singleton instance here of our Cosmos client. We could rely on, of course, our bindings here, and deserializing the Event Hub payload, and now using Patch API, the new Patch API, to change the order status, now order executed, and adding a new attribute here to identify the last modified date for this order. Now in this function, we are storing the detailed executions as we firstly showed, and pretty much deserializing Event Hub payload and using a different API create item to store the detailed executions in Azure Cosmos DB. And lastly, from our APIs, our processor APIs, we are again using Azure Cosmos DB change feed and Cosmos DB trigger to store, once the order has been fully executed, we now have to change to update the customer portfolio. So in this case, we are using a different concept here. We are using hierarchical partitioning. So the collection is partitioned by customer ID and asset class. We could have different asset classes for the same customer, and checking whether the record already exists. So if the customer has already a position for Microsoft stock in this case, and if yes, just deserializing the object and using in for patching in later in this function. If the record is does not exist in the destination, we just need to create a new portfolio and create the item. And here we are using a different approach. So we are using, again, Patch API to increment the quantity, either with a negative or a positive quantity, and adding the less modified as well. And depending on the action here, you're going to set the new average pricing or adding a TTL for automatically removal of this data. And again, calling the Patch API to change the object. So a couple of takeaways of this demo. So as you could see, partition key is the key for scalability in Cosmos DB. So choose wisely. NoSQL modeling is very different from our relational modeling. So keep an eye on modeling for massive workloads. We have a great event-driven document-based data model, so we can pretty much deserialize and serialize objects very easily from our code. We could rely on CQRS pattern as well for different data modeling and changing data for consumption. We also have a low latency guarantee for small documents for either point read operations or writes. Streaming is also much cheaper than batching, so that's a good thing for our event-driven architecture. As you could see, Azure Cosmos DB change feed is a Swiss Army knife as well, so we could rely on change feed for referential integrity, or even creating materialized views in using a CQRS pattern. Or as well, we could use change feed for downstream event processing, as well as integrating with many other Azure services. We also have for Cosmos DB great integration, great SDK support, such as .NET, Java, Python, and others. And Synapse Link integration for near real-time operation analytics. And as you can see in this demo, we have a great integration with Azure Functions. So either in a platform as a service or inside Azure Kubernetes Services and KEDA. For this use case, whether you need custom hardware or specific scalability requirements, if you need isolation and a secure network, and you can either benefit from Azure Functions with this integration in the Azure ecosystem alongside existing Kubernetes services. So if you haven't tried Cosmos DB yet, get started, and you can try it out for free without any credit cards. As well as we have several documentation for Azure Cosmos DB best practice and a full path of our learning, and also a specific Azure certification for focus on Azure Cosmos DB. So thank you everyone for watching, and have a great event.